Alzheimer's disease is an age-related disease, however, it is not a normal part of aging. The surprising bit about Alzheimer's is that a person may have moments of absolute clarity where they remember everything, but followed by episodes of confusion and disorientation. In regards to China's new drug, the significant causes that will be discussed are the age, the vascular system, amyloid plaques, and tangles. Age-related changes that may harm nerve cells and contribute to Alzheimer's damage include atrophy, the shrinking of certain parts of the brain, inflammation, production of unstable molecules called free radicals, and the breakdown of energy production within cells. The diagram shows the left side of the brain hasn't gone through atrophy, while the right side has gone through atrophy. In regards to the vascular system, if it fails to deliver sufficient enough blood and nutrients to the brain, or if the brain lacks glucose needed for activity, chronic inflammation sets in, causing microglial cells to fail to clear away debris around the neuron. This means astrocytes will then react to the distressed microglia. Eventually, the neurons will be unable to communicate and die off, causing the brain to shrink. The toxic change in the brain is believed to be due to two proteins called beta amyloid and tau. Beta amyloid clumps into plaques between neurons, and once this amyloid reaches a tipping point, there's a rapid spread of tau. Tau come in bundles called neurofibrillary tangles, and the abnormal tau accumulates, causing massive tangles inside the neuron. Although the genetic factor of Alzheimer's is important to discuss, it is less relevant when talking about the drugs China's made. Drugs are being experimented with to reduce or clear the increase of tau and amyloid proteins in the brain. Therapies are being investigated to target the vascular system, the glucose metabolism, and inflammation regarding the brain. Shanghai Green Valley Pharmaceuticals, a Chinese pharmaceutical firm, has received conditional approval from the country's regulatory agency for oligomannate. Another name for it is GB-971, and it improves cognitive function in mild to moderate Alzheimer's disease patients. The drug demonstrated the ability to block the abnormal rise in intestinal flora metabolites, regulate peripheral and central inflammation, decrease deposition of amyloid proteins and tau hyperphosphorylation, and improve cognitive function in preclinical studies. Oligomannate works to alter the bacteria in the gut microbiome to affect changes in the brain. Finding the mechanism of oligomannate was discovered through mice, which were used to model and test the drug. The experiment was done with human subjects through a randomized, double-blind, placebo-controlled parallel group phase 3 trial conducted over 36 weeks in China. It was discovered that oligomannate led to statistical improvement in cognitive function at week 4. It was also sustained for follow-up assessment visits. The drug side effects were comparable to the placebo and was deemed safe as a result. This research was led by Mayo Zhang at the Shanghai Institute of Materia Medica. The mice were made to show physical and behavioral symptoms similar to Alzheimer's disease. The researchers drew blood from the feces to analyze the presence of immune cells and cytokine. They found that the oligomannate treatment altered the mouse's gut microbiome by increasing levels of some cytokines in the brain while decreasing others, and they also reduced the number of pro-inflammatory helper T cells in the brain and blood. Liping Zhao, a microbiome researcher, states that not all of the paper's data supports the hypothesis that oligomannate reduces neuroinflammation by changing the gut microbiome. The bacteria state on the left produces an endotoxin that increases inflammation, but it became more abundant in the mice treated with the drug than in the mice that were untreated. Liping Zhao also stated that bacteria in the genus Rosburgia was a well-known beneficial group of bacteria, and it reduced inflammation, but this decreased in the experimental mice that was treated with the drug. A total of 818 mild to moderate Alzheimer's disease patients completed the initial human trial set up by Green Valley. Early next year, Green Valley plans to conduct a global phase 3 clinical trial in the US, Europe, and Asia to support its regulatory submissions worldwide. It's the first Alzheimer's drug to be approved since 2003, and it works to decrease neuroinflammation by utilizing the gut microbiome as a summary. Unlike other approved drugs, it utilizes an entirely different pathway instead of direct. Unlike other approved drugs, oligomannate utilizes an entirely different pathway instead of directly acting on the brain or plaque deposits around the neuron. Although the results are promising, it must be first confirmed before having any conclusions drawn about the drug. If proven to be effective, GV971 could be a beacon of hope in regards to Alzheimer's research.